Yeah. Yes. 今天学到。
您解锁，请启充话筒。
Okay, good morning to everyone. It's been raining for the whole day since yesterday, right? Even our tree can't stand anymore. You guys see the tree fall down today? Yeah, tree. Yeah, falling down near the tennis court. Yeah. Did you guys pass by? No, using the bridge. Oh, you got the bridge. Yeah. So if you see the tree falling down, right, the soil is like getting very wet, very loose. Okay, so it means that if your foundation is not strong enough, even the big tree will fall. Foundation is very important. If you go around, you can see the soil is very loose because stopped by the water. But I think it's not clear from here. Yeah. Okay. Yeah. So, any question you want me to discuss today? Maybe you can discuss question first, and then I can give a summary. Any question you try and you want to discuss? After you haven't sent me your uh, request last time, I'm going to do it now.
Different
Mhm.
from your.
Mhm. You can give me the number. Yeah. You can give me the number. Give me the number.
Okay.
Which one? Which number?
4.22.
4.22. Okay, let's look at 4.22. Four point two two. A bit stuck. 4.22. Okay, yeah, 4.22. Yep. So which part you think there's a problem?
Like this because of the I think because of the question.
Okay.
For this reason, the concave up and concave down.
Which one? Okay, sure.
Yeah, and concave down.
Okay, sure. Let's check the calculation here. Everyone tried this question here? 4.22. Should we turn off the light? Arthur, do you want to sit here? Maybe you can sit here. You can speak closer. Okay. So let's check this question here. Given the function gx and I want to find the interval of complexity in t. So we want to find the second derivative, right? So let's start with the first derivative. So this is the quotient x over 1 plus x squared. So what's the quotient rule? Maybe we can recall what's the quotient rule. If y equals to u over v, then dy dx equals to v du dx minus u dv dx over v squared. Is this formula correct? Yeah. Okay. So let's check what's our u, what's our v here. So our u is x, and then v is 1 plus x squared. Right. I think it's okay. And then you oh, so it's my minus sign swap?
Yeah.
Minus sign swap? Yeah, okay, good. So I think there is this kind of problem because I applied the wrong formula. So if I put a minus sign here, and then here become plus, here become plus, here become minus, and then here become plus, here become minus. Is it better for the first derivative? Wait, so become 3. Become 1 plus 3 x cubed, x squared.
Like this.
Not like that.
Plus minus 1 minus x squared.
Oh, wait, let me check. You mean this part still wrong?
No, this one is minus 2x squared plus 1 plus x squared.
Wait. So let's see what's going on. Here become minus, here become plus. Oh, okay, good. Okay, so it becomes 1 minus x squared. And then can we cancel anything out? Not really. Yeah. So this is the last form. Like that. Like this. Okay, so then we need to keep differentiate with respect to this. Any way to make it simple? How about do this? This is 1 plus x squared over 1 x squared. Minus 2x squared and 1 plus x squared. What if we simplify to this? Maybe it's easier to do differentiation later. Okay, I think I prefer this. Okay, so let's remove everything of this. Okay, and then we do differentiation. Again, So minus uv prime over v squared. Okay, on the other side, we get plus x squared du dx 4x minus 2x squared times 2 times x squared times 2x over v squared. So far, so good.
Four.
We run.
Power of 4.
Where? Oh, yeah, thank you. So square the square got 4. Okay, so remove one of it. Okay, and then I think we should expand it. So 8x cubed. Okay. Minus 4x. X minus 4x cubed. Plus x. I think we simplify further. How about we simplify further? So minus 2x x cubed plus 4x plus 4x cubed. X squared over cube plus 2x minus 2x cubed 4x plus 4x cubed. So I think we can pull out factors. How about we pull a 2 out? Minus 2x. We get 1 plus x squared plus 2 plus no minus
Minus 6.
2x squared.
2.
Sorry,
6x plus 2x cubed.
yeah. So what are you mentioning here? So do we get this? 3 minus 3x squared over 1 plus x squared cube. And then we can pull the 3 out again. 1 minus x squared over. Is this what you get? Not really. So which step got problem again? 3 minus x squared. Where is the 3 minus x squared? Oh. So here is 3 minus x squared. Okay, good. So then we just keep at this step then. This one okay? Okay, same. This one okay? Okay. Okay. All right. So everyone happy with this? Okay. So then we want to check where is it greater than 0, where is it less than 0. So let's check it. All right. Wow, so many x to check. Okay, but that's fine. So the bottom part here. So let's split it step by step. Since x squared is always greater or equal to 0, okay, the denominator, the denominator 1 plus x squared cube is also greater than or equal to 0. Okay, so you just need to care about the numerator. You just need to care about numerator. But let's check the numerator. So if x is greater or equal to 0, this means that minus 2x will be greater than equal to, wait, so minus 2x will be less than or equal to 0. Okay. If x is less than or equal to 0, then minus 2x will be greater than or equal to 0 because negative will swap the sign. Okay. So we need to check another term. Okay, let's check the other term. For x minus x squared. Okay, so how do we know about this? So the technique for this function is you need to look at the root of this 2 square root 3 and minus square root 3 here. Okay, because this is a negative quadratic, so you draw a set face. So from here, we see that if x is less than or equals to minus square root 3, then 3 or x is greater than or equals to square root 3, then x is, sorry, and 3 minus x squared is less than or equal to 0. Yeah, because this refers to the side here, to the start. Yeah, I think the screen is stuck. Okay, coming up. Okay. And then if x is in between minus square root x and square root x, okay, then x minus x squared is greater or equal to 0. This is the middle part here. So this line is x. Bit delay. Okay, so far so good. Did everyone know this smiling face and sad face method here? Did you learn in your high school? Sad face, smiling face, sad face. Okay. So look at your x squared. What's the sign for it? If it is negative, you draw a sad face. If it is positive, you draw a smiling face. And then you compute the root, okay, to label this intersection. Okay, so if we put all these together, what did we see here? So let's put all this information together. Okay, so we got two functions, right? One is negative 2x, and then the other one is 3 minus x squared. Okay, so what's the sign here? Maybe we put another product here, minus x times 3 minus x squared. So here is sign. So there are few region you need to take care about, right? So one is before 0, one is after 0, one is square root 3, one is negative square root 3. Okay. So everything before 0, negative 2x will give you positive sign. Positive, positive, and then negative, negative. Okay. I mean, you can see this from your negative 2x graph also, right? Your negative 2x should look like this. Okay, positive on one side, negative on the other side. How about 3? I'll draw the picture for you already. Actually, this is how we read the sign. And after square root 3 is negative as well. And anything in between is positive. Okay, so if you take the product between this sign, what do you get? Plus minus is minus, plus plus plus, plus minus is minus, minus minus plus. Okay, so altogether, what do you get? So f prime x is greater than 0 will give you that x is in between -3 and 0, and x is greater or equal to square root 3, or f prime double prime x is less than 0 if x is less than or equal to square root -3, or x is in between 0 and square root 3. Is this what you want? Okay. So Arthur also got this. Did I have a picture here? Maybe I don't have a picture here, so that's why I make mistake, right? So because you are doing at home, so probably you can try and plot this x over 1 plus x squared. Okay. So let's do it. Maybe in the exam setting, you cannot draw the graph that we give you because it could be the case that we want you to prove it using this derivative method. So, but at home, you should be able to verify it. So let's check it. X over 1 plus, where's the plus? X squared. Okay, seems like I plotted the sky before, didn't I? It's not here, maybe. Okay, so let's bring this picture up. Copy. Paste here. Okay, so let's look at our result. Let's verify this on top of this graph here. Let's crop it a bit. Okay, crop it. Okay. So square root 3 is very important. So let's, where's square root 3 again? 1.57. Square root 3. 1.7. 1.7. So it could be somewhere around here. Okay. So it says that when f double prime x is greater than 0, okay, so maybe let's make a conclusion here. Hence, for square root x less than in between 0 and square root 3, f is, so greater when the second derivative is greater than 0, is it concave up or concave down? Concave. When second derivative greater than 0 is concave down, you sure? Down? Down. Wait, yeah. Let's check. Okay, when second derivative is greater than 0, it is concave up. Okay. So maybe you can remember one thing. So greater than 0 is positive. Positive behavior. So up is also positive. And if it's less than 0, negative. So it's down. Okay, so maybe you can remember like this. Okay, so greater than 0 is up, less than 0 is down. But there's one case is opposite, right? Which is the second derivative test. Okay, second derivative test is a bit different. Maybe we should compare it because I think most of the students also remember it wrong because I also make the same mistake before. But if the second derivative is less than 0, it is the local maximum. Although it is negative, but the point that you look at is a maximum. So maximum, we think of it like a positive thing, right? Maximum. But if it's greater than 0, then XD is a local minimum. So don't confuse these tests here. Okay, let's go back to this. So F is concave upward. Still remember what does it mean by concave upward? Meaning that the graph is on top of your tangent line. Okay. And for x less than or equal to square root 3, and in between x and square root 3, f is concave downward. Okay, so let's see whether this graph fits your description or not. Okay, so there are two parts that's concave upward, meaning the graph is on top of your tangent line, and then there are another two parts is concave downward, meaning the graph is below your tangent line. Okay, so let's see. We have this graph on our hand here. So let's see. So this part is concave upward. So let's see if it fits or not. Okay. Okay, so square root 3 is kind of a inflection point. Okay, so it's kind of an inflection point. And it's very small, huh? It's very small. So maybe can I zoom in a bit? 1.7, did you say just now square root 3? Can I check it? Square root 3. Square root 3. 1.7 something. Okay, 3.2. So let's look at this zoom in big enough. Did we see the inflection point or not? 1.7. Okay, somewhere around here.
Right, another.
Yeah.
Like,
What?
x equal to
Oh, okay. Oh, I get what you mean. So y equals to 1.7, something like that.
y.
Oh, yeah, x. Thank you. Oh, x. Yeah. Okay, so this point here should like split the tangent line from above to below. You kind of see it. Can kind of see it or not. Very subtle different, I think. Very subtle. Almost linear. Almost linear. Yeah. So can you see a big curve from the top and then curve below at the bottom? Can see or not? So maybe I screenshot it and then I draw it and let you see. Okay, so can you kind of like see this curving at the top on the left hand side and then curve a bit downward, okay, after the right hand side. A little bit, just a little bit. Very subtle. That very subtle. Okay, so it's kind of a inflection point. Okay. Does it make sense?
the question.
Sorry?
Yes.
Yeah.
Like,
Mm.
can you scroll up?
Scroll up, yeah.
Like,
Which part you want?
to our, not this next one.
Second derivative?
Not when we
This one.
find
Yeah.
like some signs and
Yeah.
can I like find this sign? Like we find our local maximum, local minimum. Like first we find first derivative and then equalize it to 0 and find some roots, some numbers.
Yeah.
And after it we make a second derivative
Uh-huh.
and our numbers that we find earlier, we put in a second derivatives and find some numbers other. And if it's, how can I say? It's like our graph is a concavity is a between these two local points. Like I think it's my like.
Is it always true? But inflection point is not counted as critical point, right? So you might miss the inflection point. For example, this inflection point happened at square root 3, right? It's not, you cannot find it in the critical point.
Square root 3 is
Yeah.
It can be in a critical point.
How?
Oh
No. inversion point because the derivative is not zero, and then derivative exists is not a singular point, and it might not be a boundary point, so it won't be a critical.
So it's only with this kind.
Yeah. Yeah. So you should analyze based on your second derivative here. You should analyze based on the factor that happens here.
So first,
First derivative. This part. Yeah, it's quite different now. Second derivative and first derivative could be very different. Yeah, could be very different. Yes.
Zero. X. Yeah.
Hmm.
So we can put it like this X.
Out.
Like
Hmm.
we can. So my yeah, if we put it under first bracket, then we cannot take the zero. We just take one to.
Oh, you mean open interval? Did I choose the 0 part?
Yeah,
Wait, let me see.
equals zero.
Oh, yeah, sure. So this is the mistake we did in quiz, right? We don't want the endpoint to be included. Yeah, this is not equal. Yeah. Penalized. Huh?
Secondary.
Okay, sure. Yeah. So thank you. Yeah. So we shouldn't put this equal sign here, right? We already reminded in the quiz too. Yeah. It should be open. Yeah, because if you substitute 0 or this endpoint into your calculation, you also get 0 actually. This is what you meant. Yeah. But I mean in the quiz 2 already say that the concativity is not happening on the closed interval. It should happen in the open. Okay, so this one is actually wrong, right? This one. Yeah. So be careful, be careful because maybe I tell you another logic actually. If in MAT, right, you write like this it's okay. You know why? You know why? Let me teach you a bit logic. So if MAT write like this, I think I accept it because less than equal by definition is less than or equal. Okay, so about this or, right, if you have one side true, the other side false, it is still true. This is logic. You understand? So if a proposition is or, true, false, true. Okay, one of them is true is enough. Okay, but if it is and, then it's another thing. Okay, and you have to be both true. You understand? You understand what I said? Okay, but we try to keep it. We try to remind you not to take the equal sign in this class, so that's why we penalize you. But in terms of logic, it's fine because this is the proposition, all proposition. If P or Q, one of them is true, then the whole thing is true. Okay, makes sense? Does it make sense? I think you're gonna learn discrete math, right? When are you gonna learn discrete math? Next semester. Yeah. Okay. True or false is true. Still true. If you want true only, there's the and statement, P and Q must be true. Okay. Any other? Which number? No, it's okay. You just shout out your number and then we can go through it. Please don't use this kind of thing. Please don't use this.
I cannot use this.
No, you cannot use it.
So the answer should be root 2 square root 2 over 3, not minus 2 square root 2 over 3.
You mean whether it's the sign different or not? So let's check 2.51. Okay, let's go to 2.51. Okay, then I will update this part here. Okay, I will update this solution here. So let's make a note here. Update. Yeah, I'll update lecture 10 here. 2.51, right? Okay, let's look at 2.51 here. Okay, so Arthur says there's something wrong here.
No, I'm not sure about it.
Okay, let's check. No, it's okay. That's fine. We can discuss. So find the horizontal and the vertical asymptote of the graph fx. Vertical asymptote is 5 over. It should be 5 over 3. Yes. So let's check one by one. Okay, let's do it. Let's do it together. Yeah, let's do it. So to find horizontal and vertical asymptote, right? So let's start with one of them. Horizontal asymptote. Okay. So let's look at horizontal asymptote. So what's the behavior of the horizontal asymptote here? So if you look at this picture here, okay, so the red line is the horizontal asymptote. Okay, so what happens if you want to approach this horizontal asymptote here? This is the behavior when you graph go to infinity or negative infinity. Okay, you will get very close to a horizontal line. Okay, so what you need to do is you need to compute lim. Why am I not writing? Okay, so we need to compute lim x to infinity and lim x to negative infinity. Okay, so we need to compute both of these. Okay, so for the positive part, I already computed. I think it's fine, right? Nothing wrong in this computation. But I missed one calculation. I missed the negative one. Okay, so if we compute the negative one using the same portion here, what do we get? Okay, then there's something different in the denominator, because instead of you put a very large positive number, you put a very large negative number. Okay, then the negative number will cancel with the negative sign. So what happens here? You are adding a very small number. Huh?
Yeah, very small.
Very small number.
It's
It's still the same.
Yeah, it's same.
What's wrong with this? Let me see.
Just there is only one horizontal one.
There's only one.
Yeah. Second one is not simple because it like intersects with the frame.
If you want to
Sure. We should.
square root x, if I want to square root x square, we get plus x minus x. Not like this.
X minus x. Say again.
If we want to square root x square, yeah, inside the root 2x square.
What do you mean? You mean x square like that? You mean square root x square like that?
Yeah.
But do we get the second thing to be your horizontal asymptote? Let me see here.
It means that if we think that x is infinity, is big, then we can thought that 2x square plus 1 equal 1 is so is smaller, so 2x square. So square root 2x square equal I just think that root square root 2 plus minus x like this. Then if we take x belongs to minus infinity, then
let me think this. Oh, what's wrong here? So what did I do here? Let's check. So let's see, what do I do here? So what I did was I divide by x square over x square here, right? So is it true that, let me think, will I do this instead?
Plus minus 6.
Yeah, so if this case happened, there would be a, let me think. Seems like this is not trivial. Is there another way to see this? Let me think. So can I, if I bring the square root, yeah.
Maybe like first like square root 2x squared plus 1 divided to the 3x minus 5, 3x minus 5.
Yeah.
And we put minus here, like minus minus, so minus enough, like
You mean to pull the minus out?
yeah, pull the minus out like to the front, you know?
Yeah.
So it can be
Right up.
it helps like and in the derivatives here in the
Derivative.
no denominator and
Numerator, denominator,
and in the bottom what's called
denominator.
yeah in there is only 5 minus 3.
5 minus 3, yeah. How it helps.
You want to say that minus 3 into minus infinity, like this?
No, I think what we divided by is not x squared, right? It's actually square root of x squared. Is it true? Get what I'm saying? So, okay, I guess we need to rewrite this thing. So let's rewrite this. So square root 2x squared plus 1, 3x plus 5 here. So what we did was we multiply by this guy. Maybe we can use L'Hopital rule to check our answer also, right? Since we already learned L'Hopital rule now. But let's use this old way first. Is this the real thing that we should do? Or I think just now what I did was I just multiplied this. I think these two are quite different. Do you think these two is the same or different? It's different, right? Because square root of x squared is always positive. Yeah. And these two are actually quite different. Yeah. In particular, that's the minus sign that we miss. Yeah. So one thing I think we need to remind ourselves is like square root x over square root y is equals to square root x over y. Like that. But square root x over let's say y might not be square root x square root x over y squared like that. True, right? Because you can think of a number, right? You can think of number that this doesn't hold, right? So something we miss here. So square root x, let's say square root 2 over, let's say, mm, mm, negative square root 2, for example. Okay, it's not equals to square root of 2 over 2, which is 1 on the other side is negative 1. Okay. So I think this is the mistake we made just now. Does it make sense? Okay. Okay, so I think we need this square root thing coming. So if we have this square root to come in, then our calculation will be slightly different. Okay, will be slightly different. So
Yes,
yeah,
pull out
yeah.
of the root x.
Okay, so let me do it. Sure, let me do it. Delete. Okay, so what we should do was we instead of so inside here is still the same, 2 plus 1 over x squared, but outside here is little different. So we divide by these two things here. But this two thing here is equals to limit of x to infinity of square root of 1 plus x squared over x 3 times x over modulus of x minus 5 of modulus of x, like that. Is everyone okay with square root x squared is equal to modulo of x? Everyone fine with this? I think we didn't stress on this thing here, but this is what happened. Because if you put negative number x into x squared, you get positive square root of positive number, so still get positive. This is what modulus x can do for you. Okay. In this case here, what we get was lim of x to infinity here. What we get is square root 2 plus 1 over x squared over 3 of x over x minus 5 over x. Okay, because when x goes to positive infinity, all the x's will eventually become positive. So modulus x will be positive. And so this side here cancel, and then this get what we had before, which is square root 2 over 3. But on the other side, okay, on the other side, what happens here? What happened to this portion here? Because when x go to negative infinity, then your x will become x over negative x. And then on one side, you also become negative x, right? Okay. Then very good. About let's write it here. 2 plus my x times x over minus x is 5 over x. Okay. Over minus 3 plus over x. Okay, so in this case here, you should get minus square root 2 over 3. So the minus sign comes from the minus 3. So that we really get this picture here. I didn't realize that I didn't get this. Okay, and then for the vertical asymptote, I think I substitute the wrong number here. Should be 5 over 3. Okay, actually, some people ask me how to find all the vertical asymptote. How to find all the vertical asymptote. So one way to guess the vertical asymptote is, can you make this function as large as possible? Okay, one way to see it. So if you want to make this function as large as possible, that means you need to make your denominator as small as possible. Okay, so you want to find some x that when you sub into here, you will go to 0. Okay, this is one way to see it. I think for this class, this is the only way to see it. Yeah, to find it. Okay, for the rest of the point, you can see that square root function is pretty continuous at any positive value. And then the denominator is also continuous. So at other points, this point is defined. Okay, yeah. So if you want to get more vertical asymptote, right, you need to have more way to make this denominator 0. So more way meaning maybe you have different factor coming out, or you could have a periodic function that can evaluate to 0 at this point. For example, tangent x, sine x, cos x. Okay, so at every period, you have like 0, 2 pi, so on, to get evaluated to 0. Okay. Yeah. Any other question? Yeah, we can go a bit over time if you have more questions. But if you need to run, then you could run again first. If people still have questions, can stay a bit longer. If not, you can go back and do your repetition. Yeah, any question?
Find our asymptotes only with limits.
Yes, only with limits. Yes. Okay. Either you take limit to infinity and negative infinity to find the horizontal asymptote, or you find a limit to some point that goes to infinity to find your vertical asymptote. This is the only way to show it.
Like how we show that this some point is going to be or minus. Like in a graph, we should.
Oh, you mean?
Like I know that answer vertical asymptote is 5/3, but
Okay.
how I should show it?
How you should show it? Or you are asking like why is it infinity and negative infinity from this line here? Okay, I think this is a very good question. Okay, this is a very good question. I mean for this purpose of this course, right? If you can recognize this, we can acknowledge you already. But you ask a little bit more. I can show you how to do it. Because every time I just say it in words, right? I didn't really write down what I say. Because we acknowledge you if you can recognize these two limit here. But I can write it down for you now. Okay, so let me write it down for you. So if we take limit from x to 5/3 from the positive side, so this positive side is very important. Okay, so from the right hand side here. So this number, when you put into the top and bottom, what happens here? So if you put at the top, it's just some number. Put at the bottom is also just some number. But now we want to argue that the bottom go to 0, actually faster than the top. Is there any way to do that? I think there is, right? Just now what we do is what we need here. So we could rewrite this again. Because this is a positive part already. So then we can make this limit here to be equal to 2/1/x² over 3 minus 5/x, like that. Okay, so I think in this form it's easy to see, right? It's easy to see here now. This form is easy to see because the top is continuous, so you can bring the limit in.
My mind is important, like in a root 2 plus, I think.
Where?
In a root 2 plus, not in a
root 2 plus. Okay, plus. So in this case here, you can see that at the top, you are approaching some number, but at the bottom, you are approaching also to some number, which is 0. I think from here, you can see this is quite good. Okay, similar for the bottom case. Is similar for the bottom case. So the bottom case, you will get negative. Why? Because the difference here is negative. Because you're approaching from the left-hand side. So this number here will be less. Okay. Yeah, did I compute the from infinity side? Did I sort these to infinity? I think I should sort these to infinity, right? Because if you are coming from the right-hand side, 5/3, this number here should be greater than 3. Huh? 5. You get what I say? So maybe we try some number. What's the number that's greater than 5/3? Maybe 2? 2. So let's try 2 here. So if I have 2 here, 3 minus 5/2, what do you get? Oh, it's less than, yeah, it's less than 3, so that's fine. Wait, let me see. Is it correct or not? So you're approaching from the right-hand side. So okay, so let's write down something here. Maybe if x is greater or equal to 5/3, that means 3x greater. Okay, then we are good. Okay, 3x minus 5 is actually greater or equal to 0. Yeah. Okay, good. So if x is less than or equal to 5/3, then 3x minus 5 is less than or equal to 0. Okay, so that's why the denominator becomes negative. Okay. Maybe we don't include the equal signs because we don't care about x at 5/3 actually. Okay, so that's why we get the right sign here. Okay, any other question? Feel free to ask. But the thing is, you don't panic. Okay? If you panic, then everything will go through. Okay, so we just solve it step by step, step by step. Okay, if got mistake, we solve it. If it's got mistake, we solve it. Okay, so please don't be panic, and especially when you do the exam question. Because a lot of my students will say, "Oh, in the exam I cannot do," but when I work out the exam rule, I thought of the solution already. So please don't be panic. Okay, don't be panic. Just do step by step. If make mistake, correct it. Make mistake, correct it. That's it. Okay. Don't be panic. Okay. Any other question? Questions? Okay, ready? Ready for exam? Not ready. Hey, no problem. Okay, so far so good. Okay, good luck.
Thank you.
Okay, you too. How about the rest? More questions? Yes. What do you mean? Which question? Which question? Do we have lecture question? If anyone want to leave 11 o'clock, you are feel free to leave. But if you want to stay and listen and ask questions, you can stay a bit longer. Yeah. And maybe let those who want to leave first. For the rest can stay. I'm still interested. Just stay. Just sit down. For the one who want to leave, you can leave. Latest questions.
Yeah. So I asked Gemini to find the travel and the answer from Gemini is actually about the mastermind to the why to ask for.
If you can change the way. Okay. Because sometimes implicit function you can't really change it back. 什么？
如果只有一个那个辅导的时候，就是辅导数，那如果你什么时候是要非常完整的，或者你需要换人换外如果然后如果哪些自律然后我就问你
OK sure so 对了，等全部人使用先，我们继续。Yes。
我是他那个反3条函数的条例会给
会，如果比较难的我们会给。OK， wait, we can continue. You want to go home? Okay, maybe one by one. Okay, so excuse, hello， 你们还在吗？还是你们要走先 ？OK， 你们走先，拜拜。好，加油！ Okay, so someone asked about chain rule, right? So for the chain rule, quotient rule, product rule, right? If that's just constitute part of the steps, maybe you just write down what are the variable you make, like what is the change of variable you make. You don't need to write the full step down because during your differentiation, we can sort of see step by step what you are calculating. But to be sure, you can just write down your change of variable. You get what I say? For example, U, V, you set what's the U, set what's the V. And then set what's your Y, set what's your G, set what's your F. Because during your calculation, you already like do the chain rule and the product. You understand? You get what I said? No? So do you have a specific question you want to ask? You have specific examples you want to ask? Sure.
厘米的过程也不要求到那个过程
Yeah. That's what I meant. So I mean, like, okay. I think I get what you're saying. Okay, so for example, right? For example, you say that maybe that is x like that, right? And then maybe x to let's say infinity, and then here goes x. Here maybe got the square root x squared plus 1, right? Then you say that, oh, this is infinity over infinity. Then you want to use L'Hopital rule, right? Then you want to differentiate top and bottom, right? But the bottom differentiation, maybe you need a chain rule, for example, correct or not? So maybe you can, okay, first of all, you have to write down the L'Hopital rule first. Okay, and then you are using L'Hopital rule. And then if you want to be more specific on your differentiation, right, maybe you can say that, so we should use chain rule. So use the chain rule with, for example, y equal to square root y equal to square root w, and then w equals to x squared plus 1. Then you just tell me what's the end solution is like. Maybe this one is the solution like that. It's okay. Yeah, you don't need to like write, oh, y is dy over dw and then dw. Yeah, no need to write this because this is like a side step to calculate the limit. So if you can write until this stage, is very good. Yeah. Because this is to prevent that we don't know how you get the solution, right? Maybe your solution is wrong. So how do I give marks? I cannot give marks. So if you make the right substitution, then I can give marks. Yeah. Make sense? Yeah.
嗯，这个厘米我们这一个台词是 x k 等于1，是因为用了那个 local theorem 是吗？
就有点像刚才那个情况，
就是它这样的 xx 它可以约分1。
对。
然后如果说你是单独的一个 x 等于2，那么你直接就是do not exist。
来几下。
哦，
这两个情况不一样。
对，我就是说这两个，就是我要确认一下。
这个是因为我们知道 lim of 1 over x 去零的时候，这整个东西去有infinity。这个是我们假设知道。 这个，这是我们知道，
哦，
这
那
是你可以用。
他就写 infinite，他不是说写那个 do
does
not
not exist 啊，
哦，
你也可以写 does not exist，但是它也是去 infinity。
就是这样也可以是
其实这两个不一样。去 infinity 我们会说它 does not exist，但是它也是去 infinity，你懂这个意思吗？
我懂，就
就是
是
does not
它
exist 不
不
imply 是去 infinity，因为 does not exist 的情况也有这个。
也有很多种是吗？
哪一种？我想想，sin x 这个情况，sin x to infinity of sin x，这个 does not exist，但是我不可以说它去 infinity，它没有去 infinity。
对对对，
对，
就是
但是去 infinity 是一种 does not exist，
那就比如说这种考试时候我们比较
可以直接用，
就直接
可以
写
直接用，可以直接用。
OK
我们 quiz one 也是在用这个。
OK，那如果是变成这样子呢，就是 x 到一，然后这个是 x 等于
啊，这个情况跟这个情况
也都是
Same
infinity，
，yes，
或者就写这个也可以
也可以。
OK，然后
我想一下啊，我看出来。How do we define the infinite? Limit here. Do we define infinite limit? Actually, you guys can sit down and no need to stay here. Right, you can ask from your seat. No need to like rush. I'm here. No worry. So, we will be more precise using infinity if the fx really go to infinity.
哦
Yeah.
So 就它一般我写
嗯
do not exist，它有可能是它断掉了，就是它那个 x 到 a 的正跟 a 的负，它不是一个值，就写它不连续，
Yeah.
就写 do not
Definitely.
exist。但如果说这里它
如果你知
是
道 if you know that fx is really going very large,
哦，就
positive
可
or
以
negative,
写
then you
infinite
can use
OK，好的。还有这个这个四函数的公式，它有几个是，比如说这种很特殊的零一或者零有
Yeah.
后面有
我们会给，we will
比如
give.
这样子一样。
我们会给。
哦，那如果说我需要用到这个来解的话，
我们会给。
会给，
Yes.
就是它在后面那个附录那里，
就 question 本身。
就 question
We
本
will
身。
give. Yeah.
哦，那我相当于是我看到你给了这个，我就知道要往用这个来解。
Yes.
OK，
Yes.
那我不用去记这个。
Yes.
OK，那就是这些求导呢，我需要记吗？
不用，
也不用。
难的不用，最普通 maybe cos and sin you need to know.
哦，
That's it.
就是
Other than that, maybe you can derive on the spot using quotient rule. But harder one we will give you.
6 OK， just like this 的
Yeah, we
inverse
will give.
OK。那这个呢？这种 linear，它这种公式，如果说要我求的话，这个也会
Yeah， 对。
那我相当于说，我也只是看到这个，我就知道要
Yeah.
它都在 question 本身那样子。
因为给。
对了，好，谢了。
OK， 好。Yes。
This one is use do this math like this. And last day when I do this again, I just found that 6 and 0 is inflection point. So can I put it like this? That just a concave down is minus infinity to 6.
Impossible, right? What's this point? This is not a graph point.
And concave down at minus
Middle
infinity to 0, 0 to 6.
Oh, this is the
Which one is
interval.
correct? No.
Wait, I mean depends on this, right? Depends on your f prime.
It is
When is it greater than 0? When is less than 0?
less than 0 is in this point.
What do you mean point?
Yeah.
This is an interval.
Yeah. This interval. Sorry. This interval. That's but in the lecture note.
Okay, so which question is it? Which question is it? Yeah, slowly. You don't need to.
4.26.
4.26. Slowly, let's take it slowly.
I have also a question. Is linear approximation in chapter 3 important for the exam?
We cannot say which one important or not, but just wait. Which function again? 4.26. Do you want to sit down?
Yeah.
Maybe don't just keep coming here. Yeah. You can speak from your seat, it's okay. No need to rush. I'm here. I won't run away. Sorry?
Express.
You need to learn. Otherwise, there's no point you come here. So you need to learn. Please sit down. Don't keep coming to my space. Okay. So when to look at this second derivative here. Okay. So what's wrong here? Let's see.
Concave down.
Sorry?
Where the graph is concave down.
When is it concave down or? You mean I picked the wrong interval, is it? Let me see. So f prime double prime x less than 0 is where it concave downward, right? So it's when 6 to negative infinity. Correct, yeah? Negative infinity to 6. And then, yeah, output is going. Oh, you mean I missed the. Okay, I get what you mean. Okay, I get what you mean. So I think we missed something, right? Okay, good, very good. Thank you. So yes, you are right. So because sure, thank you. So so we still have another condition, right? Not that for I think okay. So I think we need to turn it around. So this is true. And then for x greater than 0, oh, we can't really. Okay, I think we need to split it out. Split it out is better. So when x is greater than 0, 4x, 4 plus 4 over 3 is greater than 0. And then for x is less than 0. No, right, it's still positive, right? We don't really care. We don't really care. Bring it back. We don't really care, right? Because this is x to the power 4. It's always positive. It's always positive. Yeah.
We can achieve 0. So 0 is the inflection point. That's why I use the interval.
Let me see that. So what happened at 0? Zero is an inflection point. Why did I get 0 as an inflection point? Did I get my second derivative wrong?
No,
Yep.
second derivative is very similar, also similar to me. But I just want to say that the interval should be like this: minus infinity to 0, 0 to 6. It cannot be the
So why is it
You can
like?
give up and 6 to infinity.
Let's see what's wrong here. Zero to 6. Oh, wait. When x is less than 6, this is positive. So this sign is positive, this sign is negative. Then why do I need to split it? What's wrong here?
6 it's negative. It should be negative.
It should be Oh, yeah. Wait, yeah.
Minus because of the minus sign.
Oh. Oh, wait, let me see. Oh, yeah, wait. So there's a minus sign here. Yeah, true. Okay. And then why do I split at 0? Why am I splitting at 0? Why am I splitting at 0? If it is less than 0, what do I get?
It's also minus negative.
Huh?
It's also minus negative if I take less than 0.
Yeah. Negative is a positive. Wait, let me think.
Because of 4 over 3, x to the power 4
Hey, wait.
because of the negative sign. Negative.
If I put -1 here, -1 back is so which part goes wrong here? If I put -1 here, okay, so let me
Okay.
Yeah.
This math, but I just want to say that can I use the interval like minus infinity to 6? Because 0 is inflection point.
So how do you prove that 0 is an inflection point?
Because if I use 0, the f double prime second derivative should be does not exist or
Undefined, yeah. Okay.
and also if I put 6, then also undefined. So 6
Sure.
and 0 is inflection point.
But our definition of inflection point is on the both side, the sign of f prime x differ, right? So you need to somehow prove that the sign change on both sides. It's not about second derivative. You need to prove the sign change. So there's something wrong with our calculation, I think. Or okay. So either the f prime c is 0 or either doesn't. Okay, so but then why we can't prove that on one side is positive or the other side is negative? Is the calculation wrong here? Is the calculation wrong here? Maybe let's use computer to calculate. See if I get it wrong. See. Okay, this is the first derivative. First derivative is okay. Okay, how about do the second derivative? Okay, second derivative looks like this. Second derivative is okay. So what's wrong here? Okay. If 6 to infinity inside here is positive x greater than 6, then 6 minus x is less than 0. So negative, negative, positive, negative, negative, positive, this one is okay. And then if x is in between 0 and 6, then 6 minus x will be greater than 0. So positive, positive, negative is negative, fine. But how about the other side? If x is less than 0, then negative x is greater than 0. 6 minus x is also greater than 0. Positive. But then x to the 4 is positive, right? So positive, positive, negative as well. But didn't match this graph, is it? Is this an inflection point? Anyone got problem with this calculation? This example. 4.26. 4.26. What did you get? 4.26 C. What do you get? But did you see like the sign didn't change here? Did you see that sign didn't change here? The sign. Sorry? Didn't change, yeah. You also get that it didn't change. So is it an inflection point? But it says that it doesn't exist, right? But it really doesn't exist there. What's wrong here? Because this derivative is correct also using the calculator. Yeah.
I just want to ask that,
Yeah.
is it
An inflection point? Okay. So let's determine this. Yeah. So let's determine this. So is it an inflection point here? If it is an inflection point, there should be a sign change, right? But this calculation, there's nothing wrong. What's wrong here? Anyone can get what's wrong here? What's wrong here? Can we get Gemini 3 Pro to solve it? Okay, let's see the calculator from Gemini 3 Pro. Ask him to solve. See. The calculation is the same. Let's see where we miss. Copy. Yes. Why not?
Whether greater zero or smaller than zero.
Yes.
So the sign is always the same.
Yeah, that's right. That's right. That's right. But mhm, only 6. But it satisfies one of the condition, right? Because f prime prime c doesn't exist. If CFC is an inflection point, then either f prime prime c is 0 or f prime prime c does not exist. But satisfy one of this. Correct? It doesn't exist. Huh? No. This is the conclusion, not the. Oh yeah. You're right. You're right. Good. This is not the if and only if statement. Good. You are right. So if it is an inflection point, then these two things have to happen. But if these two things happens, it might not be a inflection point. It doesn't go the other direction. But from this graph here, right, it seems like it is. Did I plot the wrong graph? Yeah, I think you are right. Yeah, it doesn't ask us to lower. Yes, that's right. But I'm just trying to like verify is it true what we computed. Uh-huh. Yeah, sure. So I mean like if it is concave downward, yeah, okay. So I think this graph is okay. I think it's not inflation point because you see this graph makes sense like that. Understand? So it's not inflation point. Yeah, actually, yeah. It's not inflation point because it's not the other way. So with our calculation is correct. Okay, good. Yeah, it's not the other way. Yeah, good. Okay. Okay. Felicia, got a question? Yeah. Yeah, we should have drawn this to avoid confusion actually. Yeah, you can stay there. You can stay there. No need to walk here. No need to walk here. You cannot see what you cannot see is on your iPad. Why you cannot see? I cannot see. You should talk to me. Yeah. Yeah. 3.61. 3.61. Where is it? The 3.61. Okay, 3.61. Yep. The height, the speed 4/5 meter per minute. Yeah. $60 above the ground level. So where's the ground level? Huh? Oh, you mean do we need to wait, let me see. Am I drawing the wrong picture? How fast is it ground from the 10 meters? Okay. So what's wrong here? Not from the ground. Let me see here. Let's height be above. Oh, you mean I instead of putting 16, I should put 6, huh? 6 or I put 6, right? So okay. So the setup is like this. So let h be the height of the rider above 10 meter. So this 10 meter here we count from ground level. You get what I say? Repeat again. Okay. So I set this h okay, to be the height of the rider above 10 meter. Okay, so meaning after 10 meter, I got a height here. Okay, so if the Ferris wheel turn to the bottom, is height 0 in this case. I mean, not height 0, height negative 10. The ground level is negative 10. You understand? So if this ground level is negative 10, but you want 60 meter from the ground level, so it's just 6 meter above. I mean 6 meter in h. This h will be 6. You get what I say? Because this height already constitute 10. Okay, this h is built on this 10. H is not counted from ground level. H doesn't start from 0. H start from 10. You understand? This height here, this H here, start from 10. Height of the rider above 10 meters. Okay. Okay, so that's why this H here is not 16, it's 6. Okay. After you okay? Yeah, okay, yeah. Don't be panic. Yeah. 2.63. 3.63. If we didn't say it's not, then you need just go through. Huh?
You can bring calculator.
Yeah, you can bring calculator. Yes. Yeah. 7.9是吗？4.9. What's 4.9? Antiderivative. You can disregard that actually. Not very important. 4.9 is very close to integration, so yeah. One more question.嗯，怎么画？
就是我只能和他一起用确保那个。
对，这个也很难画，其实这个蛮难画的。你需要画吗？需要画吗？还是
画一下，
画一下？
我看是怎么一个过程，就是大概要到什么程度入考。
应该我们不会考这个，但是你要画的话是可以画给你看。但是我们不会考这么难，
考那么难。
不会考这么难，除非最 denominator 已经numerator 已经很难画了，就是那个分子已经很难画了。分子要画的话，有一点像我们 quiz 的那个图。OK，bye，good luck。OK，我可以画一下，
好像有4道 question，
好像有4道 question，
还是几道 question？
差不多吧，差不多。y 这个难画其实。OK，说先画分子啊，说画 W 等于 sin x。这个图的话，如果没有记错的话，这你会画？你怎么画？
先找周期，
就这样吧。等一下，这个应该就是长这样，就是这样 I think 它的 basic shape 应该是这个，对不对 ？OK，然后你要除 x 哦，是什么情况呢？除 x 过后，
是不是这个
变短了，我想想，
就是扁一点，再
扁一点，但是它的 sin 会变，因为在 小于零的时候，正变负，负变正。
你们只要画一半就可以了，因为它是计函数。
你说 even，
可以。
它是 odd，它是 odd，
函数。
呀，
计函数，计函数。
基是什么？
就是关于原点对称，就是关于这个点。
它是 odd，呀，它是 odd 的。对，所以它是一个正一个负。呀，是。对，没错。
所以这个
它应该是，它形状也是类似这样啊，就是。想想，I think 又变回像 sin x 的样子，但是，对。
就是在某一个期间，它不是这边有个地方是会是一吗？就是这个这个点应该是4分之派。
对。
然后这个点并高。
越来越小，make sense，make sense，
也是这样子。
make sense。OK，check 一下，对，make sense。
但是我不能，就这个后面这个点我没办法确认。
哪一个点？
就是它不是后面慢慢越来越小。
对。
那越来越小的那个最高点是？
你是说这一个点
啊？对。
我想一下，这一个点的话，应该跟之前这个最高点有关系吧？
就是除一下这个点对应的那个 x 就行。
不会
改。
有可能呢，
就是它
有可能。你现在问的问题是这个问题来的，就是说我如果假设我 differentiate 这一个等于零的话，跟这一个等于零的点的关系是什么？你问的应该是这个问题，这个 critical point， 这个的 maximum minimum 跟这一个的 maximum minimum 是不是只是除 x 一下就好了？
是不是对？是不是同一个？
我感觉不是，因为你看它的 derivative 应该是差蛮远，
但每除一个，
对啊，差蛮远的。就应该没有什么线性的关系。但是你这个大体的图应该是可以去 GeoGebra 直接，你看一下是不是对的。sin 就是没有 modulus，
没事就2x 就行了。就2x 就行，不用 modulus。
为什么？
就是只要看一半就看正方。
你的意思是那个？
对，
没事，我们看一个比较好看的。
不要看。
对，比较好看。So，
如果正方向对的话，
明白，我明白你讲什么，但是就反正他做得出就让他做。哦，在这里，找到他了。对，这个。我的 x， 断掉了我，断掉了，是断掉了吗？
这个
你看，把这关掉，怎么会断掉？我想想，我知道为什么，不对哦，就算断也不应该这样断，它不可以被零除，但是为什么它会断在这里呢？想想，后面对哦，
对，后面是大概。
然后为什么会断掉？它不是应该要下来？sin 我这个不是 cos。哦，你还记得我们有一个 special limit 是 sin x over x，当 x 去零的时候是1，
不极限
极限是1，
是。
所以这个情况因为我们被 s 除了对，是这个，这一个会让你算到这个东西。OK，sin x 的时候确实是下来，但是你又被一个很靠近零的东西除掉，所以它就
又往上蹦。
对，
除的这个数越小，
没有奔得越高，就是奔得越靠近2吧。
啊，对，就是
对对对
最靠近这个，
对对对，但是它在这个点上面肯定是没有东西的，因为它不离
所以
方。
零的这个
但是它
点是
越靠
这个点
近0点的时候，它
零的时候
靠近越2啊。
零的时候是没有
零的时候是没有
没有
东西的，
零
只是
没有底线，
它附近是会靠近你算得出吗？你能够用这个算得出来吗？
嗯，
因为
就这个
你可以用 substitution 来算，其实
就替代把这个换成把这个2x 直替，就是2差不多
对对
是
对，因为你这个换成 t 过后，下面就变成 t^2嘛，对不对？t^2，然后
二乘
二跑来旁边
两
嘛，
替在下面，
然后你就算这一个东西啊，然后这个东西变1，所以2乘1是2。
这个要进，
如果要用，我们会给你，
这个
对
也不用进，
对，我们会给，如果需要的。
然后这个问题，
嗯哼，
这个问题这个指的是 chapter 2的这个，
呀，明白，我明白，我看过。嗯哼，嗯哼，呀，有什么问题？
找一下找到这个题目。
嗯，
就是
呀，
这个到这边，
你懂的，你懂，OK。
但是这一步到这
对，这一步到这一步只是我换这个，我有点 change of variable，就是嗯
就是把
嗯，
这个 n 拆掉，拆成一个1除以，就是拆成了一个2分之2，
对，没有错，这个是第一步。第二步就是把这一个 variable 换掉。
啊，这个换掉，
嗯
那这两个啊
嗯，
弄完以后为什么是负？
哦，
就是这个
嗯
原来
嗯
它
嗯，
那个上面给的是这样子，
对
是这样子的，但是这
对
个加个负号为什么也不成立？我的
啊，
疑问的点是这个。
因为我想一下，
哦，因为这个前面也是负的，是吗？
喂，对对，不是，这个前面负是为了这整个东西去连，跟这一个我们是在用这个，这整个东西去连，我们要这个 x 整个东西去连，
嗯，
然后这个减2分之n去连，就是这整个东西去连。然后为什么会有负？是不是？因为因为因为因为你可以想象我把这个负带出来，所以我要解释，
那这个为什么是负1呢？
因为 OK，我写了一个，能再写多一点这个2点几3.5是能再写多一点3.4。OK，这个哦，诶，我好像有写在这里的，我是不是少写什么东西？中文你跟我不一样，我少写了东西。
刚反正上面的笔记长这样。
就是长这样子。我这个少写的东西，这里是不是应该要有建议？让我想想，
这个是
那你跟我
这
不一样。
个这个到这边是对的吗？这个
我看一下，
这个到这边是对的。
等一下，等一下，我还需要一个
行，
啊，
这个
嗯哼，
这个成语，
所以我真的是少写了东西了，这样我就少写了，我少写了这个，对不对？然后你问的是为什么我会把简易带出来？ OK，我应该可以再补一个步骤。我要解释这样一个步骤的可以多一点。这样子，对吗？简易题
就是那个
因为我想
里面
想，
绕什么？里面绕
是厘米哦，为什么厘米罗成立啊？好，我是简易的话，我怎么可以提出去？因为它里面，OK，因为它里面那个里面 exist，所以我可以把这个简易提出去。对，是厘米罗，哪一条来？应该要在蛮前面这个 potato 是全的，对，最前面。可是这个是 positive，哦我需要的是 negative，有没有 negative 啊？下面是不是有 negative？
没有，我记得只有
就这个吧。
就只有这个里面绕。
诶，我需要 negative。嗯嗯，那个negative 是这个吧，这个是什么？应该有 negative 版本的，应该有各种 power 我都可以有，之后会有，好像之后有，记得嗯，没有吗？continuity 嘞，会不会出现在 continuity 呢？polynomial rational function，可能是用这个，用这个，因为 rational function 有 include 那个简易的情况。
嗯，
诶，可是你里面不一定是 polynomial 哦，那是不是有一个漏洞在里面？
所以我
嗯，
这个是不是省下来个负
哦，
负负的，然后一除以负
哦，要，好像是要，但是
没错，刚刚你写的那个应该是对。
我有负哈，
对，
啊，要付，因为我的概念就是这个
就是为了
x 这个
外面
x 这个
这里
x
面
对
这里面和外面的那个是能同一个谁？
对对对对对
这个意思吗？
对对
这个我懂。
对对对，
就是不是应该这个加
对
一个负，
要付，呀，
然后最后
才
就是
付
负一的
一个负，
把它提到外面去求这个利率。
对对对对对对对对对对对对，但是负一
当时上课我在想，能不能这样负一直接提
提出去的原理是因为啊里面那个
连续
对
连续辅导，
连续罢了嘛，不用客套嘛，
就连续
连续罢了，连续嘛，为什么连续？这样应该
就只有在领数之段
你说 e over x，
啊，
那就不连续了，
就是
不连续，但是它 limit exist，
因为它是趋向，
趋向对，它不
所以
一定要
不一定
exist，不
在
一定要
领数，不一定
对
要在领数
对对
continue 才能。
对对对，要讲解释这个，突然间卡住。 为什么可以带进去呢？
就是为什么负一可以出来？
对，为什么负一可以出来？之前的解释是，如果 continuous 的话，我就可以带进去，比如说一嘛，一的那一个题是一是 continuous，所以我可以把 limit 放进一的 power 里面。
啊，就是这个。
对对对对，
那或者是这个，
啊，对对对对对，因为一是 continuous，所以我就可以
然后这个
带进去。
也是另一个问题，就是
Yeah，
我从这边就是把厘米放到上面去，
对对
这个用到的是这个 number 4
啊，对
对面，
对，没有错。
这个我在考试的时候我都要写 us，然后这个东西
你可以写，但是你不写，我们应该也会给你对。
就是
你只要用对
就是
地方，
不知道
我们就
不知道什么时候要写，
你觉得要写你就写吧。
记得
哦，你不记得那名字啊？那你就不用写啊。其实不用写也可以，不用写也可以。
就我
就我们只要看到你用对，我们就会给你。
不一定要说引用
不要
这个什么什么
啊，不用啊。如果你用的对，我们就可以。但是你应该可以记吧？
就是还不止一个嘛，不止一个理论，
你是说那种 limit
其他比
law 啊？
如说什么，
比如说
IVT，然后
呀呀呀
MBT
啊，
这种我要说吗？
要这种要你用 short form 就好，因为他们两个是不同东西。如果你用错东西的话，就代表不对。
那个
你可以用
有
short
一个
form
first derivation test 那个要说吗？就是第一导定，就是求其大极小，是最大最小题，
啊，对，没有错。
那个要说吗？
如果你能够说的话会比较好啊，但是你的步骤应该已经代表你在用那个，因为你在找 first 或者 second。
那
但是
还有一个就像那个什么，有个什么
那个
rolling，
哦，Rose theorem 嘛，那个就是 MVT 哦。
就是特殊化的那个，
对，你其实把它归类为 MVT 就好。
那就是说不用说 no，
哦，你是
比如说
说
就是过程
符合那个条件
我的那个过程里面要不要写引用这个人的理论，然后再写一个
啊？
写我什么？对吧？我
因为你不写的话，不是
这个
没有，因为你不写的话，你也不知道它可以用啊。问题是，好的，
不写什么，
你刚才说的东西，
就是
如果你没有符合那个条件，你怎么能够用呢？
这个
对对对对对，OK，你可以不用检查这个啦，但是这个你肯定要检查的嘛。
就是我写的这个，
对，
但是我说我没有说引用，就是我没有
哦，呀，不用紧不用紧，因为你如果会用，就代表你知道是这个东西了。
就是我不太记得他这个名字，
不用紧，名字还好，但是至少你要，
就这个写就是了，
对啊，你要符合这些条件，你才可以用。
这个就
这个不是那么重要的，因为你会用的时候，我们就知道你在用什么。除非你不会用，但是你至少有把这个写下来，我还可以给这个分。对，
所以就是
嗯，
每一个定理的条件要写，但是这个定理的名字不一定要写。
你可以这么理解，因为你可以想象一个情况，就是你会用啊，我就知道你在用对的东西，但是呀，哎，那个简易哦，怎么解释？那简易怎么解释？真的好神奇耶。
这样跟我
OK，好，可以，我 OK，好，可以。如果我有什么 update，我再告诉你。
好，谢谢。
我想到这个，我发现我想问找，就是比如说他说，找这两个
approximation，
对，那我代入进来，我
对
看这里一个是
9，
9，一个是4，
对
这个是如何找到的？
就是你可能要去猜最靠近这两个号码的一个 square，
square
比如说，你知道 square 吗？比如说
就是平方啊，
平方，对对对，比如说1啊、4啊、9啊、16啊，那你就可以 compare 咯，这些号码跟哪一个比较近？
是这样子的，
因为我们在班也有做过实验嘛。如果你拿这一个跟9相比和4相比的话，
那肯定是这个近啊。
就
那
4比较近，4个。
是他看的是这个实际值， 对吧？就是
对，
比如说，
但是如果你拿9来 approximate，它也没有什么错啊，其实只是你没有那么近嘛。
哦，就比如说，
嗯
我用计算器，我看到这个4.6等于是2点多，
啊，你也可以这样看，你也可以这样
我是2点多，那么
看。
第一个 square 就是1，然后
哦，
第二个 square 就是4，那就显然是离4最近，所以有4
对
啊。
对对
哦，
，integer 啦，你不是说2点多嘛，就跟2最近，
哦，对呀
看它跟2近还是跟3近。
，OK 了，
如果2.6就跟3近，2点。
对，哦，这懂。然后，诶，这个 MVT 就是证明是说，在那个区间里面有一个，那个 IVT 就是说至少有一个
不是至少有一个，就是那个 FA 跟 FB 之间的数
肯定
都
有解，
有一个
有解。
呀，你可以这样
那
讲。
假如说我要求它只有唯一解的话，
唯一解
就是只有一个 solution，
呀，
那么我就 MVT，那我就能证明说它有一个解，比如并且我这个的一阶导在这个里面是很大于0或者很小于0，就说明是单调的，那就是它只会不变，那就这样子可以证明。
呀，好像是这样。呀
OK，
是
小谢老师，
OK，好，
好了，再见。
呀
linear
OK，
linearization
啊哈，linear approximate 跟 linearization，linear approximate